Okay, I'm back, and so now we want to talk about what's the difference between an AM signal and an FM signal. So you might notice that on your car you have these old-fashioned things called radios, and on the radio you can turn the dial and you have AM stations which are at a certain frequency, and then you also have your FM stations which are at different frequencies. And the question is, how does it work? So the top picture there, in this picture, the top two squiggly lines are going to represent the signal. That could be a voice that's being transmitted over the radio, or it could be music that is being transmitted over the radio. Now, in fact, it's not going to be pretty like this. So in fact, it's going to, look something like this. It's going to be really complicated because your voice is a combination of many, many, many different frequencies. And then when you blend it all together, you get this really complicated looking pattern. But just for the sake of argument, let's assume that this represents the signal that's being transmitted by the radio station. So that's going to be the music that you're trying to listen to, or it could be voices on talk radio that you're trying to listen to. All right, then you're going to have, in addition to this wave here, which is the one that's going to be modulated, you need a carrier wave. So the carrier wave is going to carry this wave. And so now this one, in this picture over here, we're first going to be talking about AM signals. So that is going to be a thing that's, let's say, it's going to have a frequency that looks like that. That is the frequency that you tune the dial to on your radio. So this is going to be what's being transmitted, so the voice or the music. This is the thing that you turn your dial to, so that you have many, many different carrier frequencies that can be used. So we're going to take this wave and we're going to add it to this wave. And so what we're going to have is the original wave. So here's the original wave right here, but it's going to have this wave inside of it. And so notice that this wave has its maximum whenever this thing has its maximum. And then this wave, which is inside of this one, is going to be at its minimum whenever this one is at its minimum. And so it's one way of adding the two waves together, and then you can see that you get this very complicated looking signal. It still has the original frequency, but can you see that it gets big and then it gets small, and it's fitting inside of this one right here. It's complicated, but that's in general how you make an AM signal. It's called amplitude modulated. So the amplitude is what is changing inside of there. Now let's compare that to an FM signal. So notice I still have the same original wave that represents the music or the voice, and I still have a carrier wave that I'm going to add to it. So these would be FM frequencies as opposed to the AM frequencies in the previous one. And we're going to put them together. So see if you can look at that pattern down at the bottom, and can you interpret what that pattern is trying to say? It's kind of hard. All right, now let's go back to the amplitude modulated. So do you notice that the amplitude on the bottom picture is changing? It's getting big and then it gets small, it gets big and it gets small again. The amplitude is changing. But look at the FM. The FM is uniform. So the amplitude is not changing. But can you see something? Notice that when this one here is at its maximum, look at what the frequency does. The frequency gets all compressed whenever this one is at its maximum, and then look at what's happening whenever it's at its minimum. When this one is at its minimum, do you notice that the distance between the waves gets larger? So it's the frequency that is changing this time, which is why it's called frequency modulated. So whenever the signal that's trying to be transmitted is large, then the frequency is compressed for that portion of the transmitted signal. Okay, then what happens? Well, in order for you to hear the music, or for you to be able to hear the voices, then we got to get rid of the carrier signal. So the carrier signal is superimposed on top of the transmission. They're both interconnected with each other. They go through the air, they go to your car, they go down the antenna, and then your radio separates the two signals. And then when it separates the two signals, then you only have the original signal that has the music, or it has the voice on it. So if you're interested in learning more about AM and FM signals, then watch that little video there, how AM and FM works, on YouTube. All right, let's take a break. When we come back, we're going to talk more about standing waves.